Welcome back to the Edmond School District Automotive Training Center. This is Hot Rod High School. And in today's class, we are going to be taking a look at what to do if you need to calculate overall resistance or current in a parallel circuit and you don't have access to a voltmeter that can tell us amperage. So coveralls on, safety glasses on, let's go to work. So maybe you're trying to calculate this because you have fuses blowing and you're worried that it's too much amperage running through the circuit causing that. Well, this is how we would go through and test that even if we didn't have access to an amperage gauge. So here we have the relationship between volts, ohms, and amps, and this is just the basic principle that all electricity works off of. So it takes 1 volt of electrical pressure to push 1 amp of electricity past 1 ohm of resistance. So resistance is the opposition to electricity moving through a circuit. Voltage is the electrical pressure force that moves electricity through a circuit. And amperage is electricity. It's the actual number of electrons that are moving through the circuit at any given time. And so the way that we relate this can be seen on this table here. So we got voltage at the top of the table, and then current or amperage down here, and then resistance over here. Voltage divided by amperage equals resistance. Voltage divided by resistance equals amperage. Amperage times resistance equals voltage. And so they're always going to relate to each other in that way. So let's take and put this into a little example of a circuit. So we have here a nice example circuit, and we're going to calculate current flowing through various areas of this circuit. So the first question here is, what is the current flowing through Z3? So let's find Z3 on our circuit, and we got here are all the Z's up here. Z1, Z2, here's Z3. And we find that this little connection point Z3 operates these 2 light bulbs right here. So how much current is flowing through it? Now we have here a little voltmeter that we could use to actually measure the current here. But remember, in our real world example, we didn't have the ability to measure current. We didn't have the ability to measure amperage. And so we're just going to do this using math. So what's the current flowing through Z3? Well, Z3 runs R3 and R4 light bulbs. If we look at our little chart up here, it says that the resistance through R3 and R4 is 6 ohms each. So we got a quick little formula that we can use to find out what the total resistance through the circuit is. And we'll just put in, remember it was 6 ohms each, so 6, then hit the inverse button, plus 6, hit the inverse button, equals, and then we want to inverse one more time, and we get the number 3. But they're not asking for what total resistance is. They're asking for current. So remember, we got to go back to that Ohm's law there, and we know that the voltage is 12 and the resistance is 3. So voltage 12 divided by 3 equals the current, which is going to be 4. So if we put 4 in here, then we get the correct number. Okay, let's take a look at another problem here. What's the total resistance? Well, we already found out that the total resistance through that portion of the circuit was 3. Let's take a look at another one. Calculate the current through Z4. So here is Z4 over here. And if we follow it down, we see that it runs light bulbs R5, R6, and R7. And it says right here, R5, R6, and R7 each equal 24 ohms. So let's go through and calculate this out. So So the first resistor is 24. We hit inverse plus the second resistor, 24 again, inverse plus 24 inverse equals inverse, and we get the number 8. Once again, though, they're not asking us for the total resistance through this circuit. They're asking us for the current running through the circuit. So the current, once again, using that Ohm's law table, that current is going to be 12 divided by 8. And 12 divided by 8 is 1.5. So let's go back in here, put in 1.5. And yeah, that is correct. What's the total resistance? We already figured that out. It was 8. Now it wants to know the total current flowing through the entire circuit. So now we got to add up all of these light bulbs all the way through in our scientific calculator there. And I'll make sure to add a link to the scientific calculator that I'm using in the description of the video here. So we got R1 is 4 ohms, R2 is 4 ohms, R3 is 6 ohms, R4 is 6 ohms, and the rest of them are all 24 ohms. So let's see about putting all this in here. So 4 inverse plus 4 inverse plus 6 inverse plus 6 inverse plus 24 inverse plus 24 inverse plus 24 inverse equals an inverse one more time. Now we got 1.043. Actually, we got a whole big long number. I'm going to just copy that real quick. But it wants total current, not total resistance flowing through the circuit. So once again, we got to use that Ohm's law. So we know that current is voltage divided by total resistance. So let's go in here and just put in 12 divided by, and what was that number? Oh, it's not letting me put that in. It was 1.043 if I remember right. Enter, and yeah, 11.50. See if I remember that number right. 11.5. Let's check it. Yep, and we are correct. Okay, one more. And what is the total resistance? Well, luckily I'd kept that one so I could paste it. And yeah, that's our total resistance number, and we are correct there too. So if you find yourself having to deal with just the tools that you have on hand, and you need to be able to figure out resistance, and you're working with a parallel circuit or current when working with a parallel circuit, that is the process. So thanks for hanging in there with me as we did a little bit of math in Auto Shop. And this has been Hot Rod High School.